What do a glow stick and a firefly have in common? They both exhibit chemiluminescence, the emission of light through a chemical reaction. While producing light is no big deal when it comes to chemical reactions, the cool thing about chemiluminescence is that it produces little to no heat as a byproduct, otherwise fireflies would probably actually be on fire. The idea behind chemiluminescence is simple. A chemical reaction occurs, causing one of the products to be produced at a high energy state, making it unstable. For the electrons to go back to their ground state, they release electromagnetic radiation. If this is within the visible light spectrum, we view it as glowing.
As we all know, fireflies glow. So do other numerous life forms, such as anglerfish and even glowing fungi that grow on or near rotting logs. In animals, chemiluminescence occurs when the animal produces pigments called luciferins, which react with oxygen in the air. An enzyme called luciferase speeds up this reaction.
By isolating this gene, scientists have been able to transplant it into many other animals and plants. The gene that makes fireflies' tails glow has been added to mustard plants, allowing them to glow faintly under a camera when touched. A modified firefly gene was put into a sample of E. coli. A volume of this about equal to a wine bottle was bright enough to read by. For animal lovers, there are genetically modified zebrafish. Fluorescent jellyfish genes are added to the fish eggs, and the gene is passed on when that generation of fish reproduces.
Another example of chemiluminescence that you probably come in contact with are glow sticks. A glow stick is basically a small brittle container within a larger flexible one. When bent, the smaller container ruptures and the two solutions are mixed, causing a chemical reaction. The two chemicals reacting are hydrogen peroxide and diphenyl oxalate. Additionally, a fluorescent dye solution called a sensitizer is added.
The balanced equation for the chemical reaction is as follows. Hydrogen peroxide plus diphenyl oxalate yields phenol and peroxyacid ester. The peroxyacid ester spontaneously decomposes into carbon dioxide. This releases energy, exciting the dye. The dye relaxes by releasing a photon, which is the light we see.